In today's video, we will be talking about similarity. Now, let's talk about the definition of similarity. If two figures are similar, they can be transformed into the other one using dilations and rigid motions. So, can be transformed using dilation and rigid motions. All right. It is good to note that similarity focuses on shape, not size. All right. Now, the textbook definition is that in order for two figures to be similar, they need to have corresponding angles and corresponding side length. Corresponding angles and side length. What this means is that the corresponding angles need to be congruent and the side lengths need to be proportional. All right, so let's take a look at what I have on the board here. I have two triangles, and let's just kind of take a look at the rules I have here. All right, so now that we talked about the angles, we're now going to talk about the sides. So the sides here, we're going to say this is 2, 3, 4, give them some arbitrary sides. And then this would be 4, 6, and 8. All right. Now, like we said, let's go through the checkbox here. So shape, not size, we see that they are the same shape given the angles, right? Corresponding angles and sides or side lengths. All of the angles of this triangle are congruent, and then all of the sides are proportional. So this triangle right here is being scaled by a factor of 2. 2 turns into 4. 3 turns into 6. And then 4 turns into 8. Right, so we check off the criteria for similarity. So these two triangles are similar. Now let's talk about similarity versus congruent. All right, we have similarity versus congruent. Similarity is same shape, but can be different sizes. Different sizes. Congruent needs to be same shape and same size. So for this example right here, we would say that these triangles are similar but not congruent because one is obviously larger than the other. It is good to note that all congruent figures are similar. But not all similar figures are congruent. Not all similar figures are congruent, given this example on the right-hand side.